Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. Today on the podcast, we are super excited to be joined by Janvi Palan, who is a senior machine learning engineer at Samsung Research America. Previously at Neon within Samsung, she led the development of conversational AI engines, enhancing human digital interfaces with emotional context extraction and advanced NLU. And she has a rich background in multimodal machine learning and generative AI. Super excited. Welcome to the show today.
Thank you. Thanks, Jaden. Thanks for the intro.
What I would love to kick this off with is, asking you a little bit about your background. What got you interested in this space in general, and how did you tell us a little bit about your journey about, becoming a senior machine learning researcher at Samsung?
Yeah. So I started my career right after undergrad, building the back end of a big data engineering product at a startup. And I realized that I loved startups. Which is funny because I'm not in a startup right now, as you really know. But what I really loved was basically owning everything that I'm doing, sort of end to end. So understanding the big data space as a first job right out of college was new to me because, even in computer science, in undergrad, you don't really know exactly what it's going to be like in the industry. So finally, when you jump all in, it was a pretty nice experience. But that got me interested in the whole big data space and then understanding the system development, distributed systems, all of those areas, the data lakes and so on. And then,
have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app, or go to spotify.com/podcasters to get started on your podcast today.
Really understanding that this is sort of the background for anything that comes above it, which is analytics, and then going forward, machine learning, and now it's AI. It's sort of the backbone of it. Of course, compute as well, but data is really what has enabled a lot of these algorithms to actually function the way that they do now. So the combination of being in early 2017-18 and the startup scene in the big data space kind of really motivated me to pursue this further, get a graduate degree in computer science, kind of try to do more research in NLP, in ML, and I was eventually graduated right out of COVID and looking for something that would fit that, give me enough R&D exposure, but also be sort of like a startup environment. My team had this we were working on a very innovative concept and product, and it had this entrepreneurial energy about everyone, and everyone wanted to build and innovate. So I think it seemed like the perfect fit. It was a lot of combination of software, ML, NLP, RL, that sort of research and development.
Super cool. Yeah, I mean, amazing. And I can just tell, from talking to you, you really have a passion for some of the stuff you're working on and what you're seeing. Specifically, what kind of inspired you to specialize in distributed systems and machine learning, particularly in natural language processing? Tell us a little bit about, your background. What got you interested in that?
Yeah, I love language. I've always been this language, math, logic nerd. And I loved solving I loved looking at etymology of words and cryptic crosswords and things like that, and how styles of languages really work. And so when I was studying math and computer science, it sort of automatically drew me to the field of natural language understanding and processing. So even things like pattern discovery in words, nearness in embedding spaces. When I first learned, I was like, okay, this is amazing because it makes sense from a language, from a graphical, etymological point of view, as well as from a mathematical point of view. And that was sort of what drew me into the field itself. But the potentials of some of the research projects that I worked on, and the research lab that I was a part of in grad school, was probably the most fascinating thing to me, which was initially in the area of computational social sciences, digital humanities. Um, so basically building model like weekly supervised models. This was again in 2019, 2018.
Okay.
So this is just about the time when BERT and these things, attention and BERT had just sort of come up before the advent of large language models as we now know. So it was still, we were trying to reduce the amount of data that we were using for supervised data that we were using for some of these models. And we wanted to identify hate speech on social media and echo chambers in social media. And I think that using everything that I loved, like language, math, computer science, logic, and being able to actually put that to what I thought was a good cause in my academic scope at the very least was very fascinating to me. And I think that kind of drew me in more to NLP as a field in general. With distributed systems, I think that the moment you sort of realize that, like I said, big data pipelines that feed into some of these machine learning models require a very strong understanding of building the systems and architectures that facilitate the training and data pre-processing. That's such a clearly important part of the job when it comes to building language models or NLP-based models. So I think that that also really drew more and more of like my academic research and coursework in that space. And then it was just part of work. Yeah.
Super, super cool. Amazing. Yeah, just like, you get like a taste of it kind of in that, and then it pulls you into the whole industry. So interesting. Okay, tell me a little bit about Neon. I understand you're working on creating like hyper-realistic digital humans. What were some of the biggest challenges in making those, digital beings as lifelike as possible? And also just like for the listeners that doesn't know, what this project was, tell us a little bit about this project.
Yeah, so we call them digital humans. So the idea behind Neons is basically an interface wherein you can connect with virtual humans over a 2D interface like you and I are talking right now, except I would be a digital human, for instance. But the hyperrealism bit is actually what we focus on, which is real-time hyperrealistic 2D visual characters that you can interact with, and they're available all the time. So as in, they're available on demand. And this that's the underlying idea. Some of the biggest challenges, as you asked, is that when you're generating, this is of course, this is all generative AI. There's a visual component to it. There's the audio component, speech component to it. And then, of course, the content of the conversation that's being spoken. When you're generating all of this, all the models that are running, these have to be, the engineering challenges are massive. So they have to be performing inference at very high, like very low latency, high speeds. And it's expensive. It requires expensive compute. So optimizing the models for inference there, as well as really even the quality problems, especially in the visual models. We're so used to seeing humans and interacting with humans that as human beings, we really perceive artifacts in human visual anatomy or any part of the face, any part of the body, behavior. We're very attuned to identifying issues with that. So the reliability of the models in terms of prediction is actually super important. And at the end of the day, machine learning models are function approximators. We're minimizing a loss function. We're not saying it'll be zero for any kind of ML model. So it's very hard to guarantee this. And so I think modeling those challenges of quality in a way that would be maybe solved with some post-generation heuristics, really identifying quality metrics, all of these things were and are, I think, some of the biggest challenges in addition to the compute and system and engineering constraints that I mentioned.
Okay, super, super fascinating. Specifically, you mentioned kind of working on the emotional context extraction and enhanced NLU for neons. How do you see this technology impacting human-computer interactions like in the future?
Yeah, it's so interesting that you asked that. So, um, yeah, so when we're talking like this, it's a different kind of format as far as podcasts go. Not all of them have the visual component to it, but
Right,
I
right.
do realize that, and listeners do realize that this does add a different dimensionality, or during the course of our interaction. So it does give all of these not necessarily verbal cues, but the behaviors, the gestures. So that whole layer of human computer interaction that we would use with a virtual human as opposed to just a text-based interface is something that I think is a pretty strong impact as far as the way that we just interact with computers is going to be. So I think that this aspect of it makes interactions extremely personalized. We we can understand a lot more about, and by we I mean an application that's running something like a digital human as the interface and not maybe a text-based chatbot. You can make the conversation a lot more empathetic or understand frustrate if it's in the, say, hospitality or customer service space, understand frustrations of users because you can detect emotional context of things. Like, we know there are sentiment analysis models and emotional context understanding models. So those are all incorporated into the understanding component of the neon. So basically, the neon can or virtual humans can understand this from a user's perspective, as well as things like sarcasm, satire. These things they're lost in translation when it comes to text-based.
Right.
So I think it just really elevates the overall human-computer interaction interface itself. Does that answer your question?
Oh yeah, no, 100%. That it's so interesting. Okay, my question for you is like, where would you see these being like used? Like, give us some use cases, like customer support. Like, when are these going to be? Assuming they're deploying these. Like, what's the best use cases you can think of for these?
Yeah, interesting. So we've started some pilot use cases. So some of them are like, one, you can imagine the usage in education sectors. Hospitality is of course a big one, like hotel concierges, especially when not as a it's I wouldn't say that it's not like, oh, AI will replace humans that bit, but especially everywhere where there is a shortage of sort of staff, or say somebody's not available at that moment of time, or there's a lunch break or something like that. So it's like, instead of having a chatbot, you have something that's more visually and more visually interactive. So that's one of those sort of use cases. Hospitality. These are some of the sectors that we're targeting, like education, hospitality, healthcare.
Okay. And like, what would that look like? Is it like a big, like a computer monitor with like a person's avatar on it and like a camera, and then you go like talk to it and it can like tell you stuff? Like, tell us about, what that looks like.
Yeah, no, exactly. It's exactly like that. So imagine like a computer screen, or it's cloud native, so it could be on any screen. But a phone or a computer screen or an actual TV screen, we're Samsung, so Samsung devices.
Perfect.
No, we don't have that yet. But what I mean is that that's potentially something that would be interesting. But the idea is that any display, and you interact with it via, just conversation.
Okay.
Like how I'm talking to you over a video call, basically.
Okay.
Yeah. So
okay. Super, super cool. So one of the things I think was probably a challenge for you in this, and I mean, you kind of like alluded to this a little bit.
Yeah. So one of the so the idea is that you use a lot of, so we have to basically model responses that drive like, we have to model signals from a user, from a virtual human's environment, that can elicit a response or a control signal that can serve as a control signal to a virtual human, and then they can act accordingly. So based on the conversation that they're having, the context of the conversation, and the emotional triggers that could have. Emotional triggers is a strong word, but basically, if it's a happy or a positive sentiment or a negative sentiment, that it could elicit a smile or a nod in acknowledgement. These sort of control signals are then embedded in some sort of shared latent space, and then we use various. I mean, we've experimented with various generative models, but the idea is to really build parametric motion models to control facial and body movement. So you have a parameterized body and face representation, much like most, you can imagine like a mesh or a body model that's model. I can't tell you exactly what it is that we use, but the idea.
You don't have to give me the secret sauce.
The idea that we basically we were able to generate sequences that can understand. That can use control signals to drive and effectively like animation sequences, but kind of in a generative manner. So the sort of models that we use are GANs, variational autoencoders. I experimented with some stable diffusion, with some not stable diffusion models that are used for motion generation, and really things that would be. These are models that are that would generate consistent motion for these sort of correlated parameters of the body and face, while adhering to physical constraints of the body's anatomy. It's also it's an important constraint because we're modeling the human body, so and human face. But these are some of the main sort of models that we've been experimenting with and we use.
So cool. Okay, so you're sitting here, you're kind of like on the cutting edge of all this incredible technology that you guys are rolling out right now. What I'd love to ask you is, what are some of the most exciting advancements that you see coming in the field of multimodal machine learning?
Yeah. Well, I'm not biased, but digital human-based interfaces are definitely one of the ones.
Pretty cool.
Yeah, especially because they have the potential to revolutionize a lot of different industries. Of course, I mean, this is such an amazing time for AI research, development. We all know, I think most people who are listening to this are fans of following the latest research and are somehow affiliated with this space. So from an application perspective, of course, there's so many applications that can be built on top of like GPT-4s of the world and their multimodal capabilities in healthcare, sports, so on. But in terms of the advancements that I see from a pure research and development perspective that are slightly more near term, like in the next year or two, I think the most important ones to me seem to be things that we're able to actually run these things more efficiently. So especially the 100 plus billion parameter. I don't know how many billion parameters there are in GPT-4. We don't know that, but those that scale models with that scale internet scale data during training, but also during inference, being able to run them with much more efficiency during training, to be doing it in a much more efficient way as well, so that you minimize the amount of compute that's necessary. Really running them on device. Those are like that sort of optimization is extremely important and probably a big field of research. Reliable video generation, which there's of course some work on, like text to video, animate anyone sort of models, but reliability metrics, quality metrics, understanding that, so that in an end-to-end way we can have multi-frame scene generation with videos, with actors. So really AI movies to some extent, pretty fascinating to me. So that, because that's the latter is also a there's a lot of areas of research there, which because we work in that space, we're aware of the limitations. So it's not just another step on top of GPT-4. So I think that's another area of exciting research for me.
So cool. Janvi, this has been phenomenal having you on the podcast today, sharing your insights. I mean, you guys are working on some really, really cool stuff. As we wrap this up, the last question I would love to ask you, based on your extensive experience and everything that you're seeing, where do you see, what are some predictions you can make about the future? Where do you see the future of AI and machine learning heading, going forward?
Yeah. So technically, like I said, there's so much scope to optimize models, to make them smaller, to make them cheaper to run, to make them more accessible. I think one of the things that I wish that we can, there's the whole innovation, I love creative innovation, I want to build, I'm an engineer side of me, but then there's also the sort of, what I hope that we can do while the disruption goes on, and that research is heavily funded in that space, is in the context of social sciences, in the context of bias, and really reducing the identifying and reducing the socio-technical harms of these algorithmic systems, right? Because there is that aspect of things which is much harder to quantify and measure, but building the right tooling, making users more aware of the sort of biases some of these models could potentially incorporate, not moderation, but just increasing awareness instead of recklessness, I think is an area of research that I hope sees more and more encouragement. Potentially an area of improvement that's also necessary is to work with policymakers so that everyone does understand the repercussions of certain harms of using some of these models, and if not mitigated properly. So I think that's definitely one of the main focuses, and I personally hope to contribute more to as well, both from an open source space and hopefully from a more formal space. And yeah, hopefully also another area is privacy. I think a lot of these models, especially on the internet scale data, do leak information. There's significant research to show that. So I think that's another area that I do hope sees a lot of advancements in the future.
Super, super cool. Well, Janvi, I'm super excited about everything that you're working on. It's been great having you on the show today. If people are interested in getting in contact with you or following along on some of the projects that you're working on, what's the best way for them to do that?
I think, so we have a website, I can share it. And I think potentially check out my LinkedIn page. I do share updates there. But yeah,
Okay, awesome. And to the listener, I'll drop links in the show notes to the website. You can check out what they're working on. Some phenomenal stuff. Thank you so much again for coming on to the listener. Thank you so much for tuning in to the AI Chat podcast. Make sure to rate us wherever you get your podcasts, and I hope you have a fantastic rest of your day.